Hello and welcome to Sean White's Solar and Energy Storage Podcast. You can find out more about Sean White at his links page at solarsean.com. Welcome to the first ever radio station 706, that's Article 706, Energy Storage Systems from the very exciting National Electrical Code. We're going to start right now with Part 1, which is general. 706.1, you want to know what that is? That is scope. The scope is, this article applies to all energy storage systems, ESS, having a capacity greater than 3.6 megajoules. That's 1 kilowatt hour that may be standalone or interactive with other electric power production sources. These systems are primarily intended to store and provide energy during normal operating conditions. Informational note 1, for batteries rated in ampere hours, kilowatt hours is equal to the nominal rated voltage times ampere hour rating divided by 1,000. Informational note number 2, there can be a subtle distinction between a battery storing energy and an energy storage system. A battery storing energy is not necessarily an ESS. See Article 480. An ESS can be comprised of batteries storing energy. See Article 706. Hey, that's where we are. Informational note number 3. The following standards are frequently referenced for the installation of energy storage systems. 1. NFP 111-2016 Standard on Stored Electrical Energy Emergency and Standby Systems. 2. NEC 416-2016 Recommended Practice for Installing Energy Storage Systems, ESS. 3. UL 810A Electrochemical Capacitors. 4. UL 1973 Standard for Batteries for Use in Stationary, Vehicle Auxiliary Power, and Light Electric Rail (LER) applications. 5. UL 1989 Standard for Standby Batteries. 6. UL 9540 Standard for Safety Energy Storage Systems and Equipment. 7. UL Subject 2436 Spill Containment for Stationary Lead-Acid Battery Systems. 706.2 is definitions. The definitions in this section shall apply only within this article. First definition, diversion charge controller. Equipment that regulates the charging process of an ESS by diverting power from energy storage to direct current or alternating current loads or to an interconnected utility service. Energy storage system definition, ESS. One or more components assembled together capable of storing energy and providing electrical energy into the premises wiring system or an electric power production and distribution network. Informational note number 1. ESSs can include but is not limited to batteries, capacitors, and kinetic energy devices, for example, flywheels and compressed air. Energy storage systems can include inverters or converters to change voltage levels or to make a change between an AC or a DC system. Informational note number 2. These systems differ from other storage systems such as a UPS system, which is a power supply used to provide alternating current power to a load for some period of time in the event of a power failure. Flow battery definition. An energy storage component similar to a fuel cell that stores its active materials in the form of two electrolytes external to the reactor interface. When in use, the electrolytes are transferred between reactor and storage tanks. Informational note on flow batteries. 2 commercially available flow battery technologies are zinc bromine and vanadium redox, sometimes referred to as pumped electrolyte ESS. Inverter utilization output circuit definition. Conductors between the multimode or standalone inverter and utilization equipment. Now we're on to 706.3, qualified personnel. The installation and maintenance of ESS equipment and all associated wiring and interconnections shall be performed only by qualified persons. Informational note: see Article 100 for the definition of qualified person. 706.4 System requirements. Each ESS shall be provided with a nameplate plainly visible after installation and marked with the following: 1. Manufacturer's name, trademark, or other descriptive marking by which the organization responsible for supplying the ESS can be identified. 2. Rated frequency. 3. Number of phases, if AC. 4. Rating, kilowatts or kVA. 5. Available fault current derived by the ESS at the output terminals. 6. Maximum output and inverter current of the ESS at the output terminals. 7. Maximum output and input voltages of the ESS at the output terminals. 8. Utility interactive capability, if applicable. 706.5 listing. Energy storage systems shall be listed. 706.6 multiple systems. Multiple ESSs shall be permitted to be installed in or on a single building or structure. 706.7 maintenance. Energy storage systems shall be maintained in proper and safe operating condition. The required maintenance shall be in accordance with the manufacturer's requirements and industry standards. A written record of the system maintenance shall be kept and shall include records of repairs and replacements necessary to maintain the system in proper and safe operating condition. Informational note on maintenance. For information related to general electrical equipment maintenance and developing an effective electrical preventive maintenance (EPM) program, see NFPA 70B-2019. Recommended practice for electrical equipment maintenance, or ANSI/NETA ATS-2017. Standard for acceptance testing specifications for electrical power equipment and systems. 706.8 is storage batteries. Storage batteries not associated with an ESS shall comply with Article 480. 706.9 maximum voltage. The maximum voltage of an ESS shall be the rated ESS input and output voltages indicated on the ESS nameplates or system listing. 706 Part 3 is disconnecting means. 706.15 disconnecting means also, and 706.15a ESS disconnecting means. A disconnecting means shall be provided for all ungrounded conductors derived from an ESS and shall be permitted to be integral to listed ESS equipment. The disconnecting means shall comply with all of the following. 1. The disconnecting means shall be readily accessible. 2. The disconnecting means shall be located within sight of the ESS. Where it is impractical to install the disconnecting means within sight of the ESS, the disconnect shall be installed as close as practicable, and the location of the disconnecting means shall be field marked on or immediately adjacent to the ESS. The marking shall be of sufficient durability to withstand the environment involved and shall not be handwritten. 3. The disconnecting means shall be lockable open in accordance with 110.25. For one family and two family dwellings, a disconnecting means or its remote control shall be located at a readily accessible location outside of the building. 706.15b, remote actuation. Where controls to activate the disconnecting means of an ESS are used and are not located within sight of the system, the location of the controls shall be field marked on the disconnecting means. 706.15c, notification and marking. Each ESS disconnecting means shall plainly indicate whether it is in the open, off, or closed on position and be permanently marked. Energy storage system disconnect. The disconnecting means shall be legibly marked in the field to indicate the following. 1. Nominal ESS AC voltage and maximum ESS DC voltage. 2. Available fault current derived from the ESS. 3. An arc flash label applied in accordance with acceptable industry practice. 4. Date the calculation was performed. Exception. List items 2, 3, and 4 shall not apply to 1 and 2 family dwellings. Informational note number 1. Industry practices for equipment labeling are described in NFPA 70E 2018, Standard for Electrical Safety in the Workplace. This standard provides specific criteria for developing arc flash labels for equipment that provides nominal system voltage, incident energy levels, arc flash boundaries, minimum required levels of personal protective equipment, and so forth. Informational note number 2. Battery equipment suppliers can provide information about available fault current on any particular battery model. For ESS disconnecting means where the line and load terminals may be energized in the open position, the device shall be marked with the following words or equivalent. Warning, electric shock hazard. Terminals on the line and load sides may be energized in the open position. This notification and marking shall comply with 110.21b. 706.15d, partitions between components. Where circuits from the input or output terminals of energy storage components in an energy storage system pass through a wall, floor, or ceiling, a readily accessible disconnecting means shall be provided within sight of the energy storage component. Fused disconnecting means or circuit breakers shall be permitted to be used. 706.16, connection to energy sources. The connection of an ESS to sources of energy shall comply with 706.16a through F. 706.16a, source disconnect. A disconnect that has multiple sources of power shall disconnect all energy sources when in the off position. 706.16b, identified interactive equipment. ESS that operate in parallel with other AC sources shall use inverters that are listed and identified as interactive. 706.16c, loss of interactive system power. Upon loss of a primary power source of power, an ESS with a utility interactive inverter shall comply with the requirements of 705.40. 706.16d, unbalanced interconnections. Unbalanced AC connections between an ESS and other AC electrical power production sources shall be in accordance with 705.45. 706.16e, other energy sources. The connection of an ESS to other energy sources shall be in accordance with 705.12 and parts 3 and 6 of Article 712. 706.16f, standalone operation. Where the output of an ESS is capable of operating in standalone mode, the requirements of 710.15 shall apply. 706 Part 3, Installation Requirements. 706.20, General. 706.20a Ventilation. Provisions appropriate to the energy storage technology shall be made for sufficient diffusion and ventilation of any possible gases from the storage device, if present, to prevent the accumulation of an explosive mixture. Ventilation of an ESS shall be permitted to be provided in accordance with the manufacturer's recommendations and listing for the system. Informational note number 1. See NFPA 1 2018 Fire Code, Chapter 52 for the ventilation considerations for specific battery chemistries. Informational note number 2. Some storage technologies do not require ventilation. Informational note number 3. A source for design of ventilation of battery systems is IEEE 1635-2018 ASHRAE Guide 21-2018 Guide for the Ventilation and Thermal Management of Batteries for Stationary Applications. Informational note number 4. Fire protection considerations are addressed in NFPA 1-2018 Fire Code. 706.20b Dwelling Units. An ESS for 1 and 2 family dwellings units shall not exceed 100 volts DC between conductors or to ground. Exception. Where live parts are not accessible during routine maintenance, a maximum ESS voltage of 600 volts DC shall be permitted. 706.20c Spaces about ESS components. 706.20c1 General. Working spaces for energy storage systems shall comply with 110.26 and 110.34. 706.20c2 Spaces between components. ESSs shall be permitted to have space between components in accordance with the manufacturer's instructions and listing. Informational note. Additional space may be needed to accommodate ESS hoisting equipment, tray removal, or spill containment. 706.21 Directory. Identification of power sources. ESS shall be indicated by marking or labels that shall be in accordance with 110.21b. 706.21a Facilities with utility services and ESS. Plaques or directories shall be installed in accordance with 705.10 and 712.10. 706.21b Facilities with standalone systems. Plaques or directories shall be installed in accordance with 710.10. 706 Part 4 Circuit Requirements. 706.30 Circuit Sizing and Current. 706.30a Maximum rated current for a specific circuit. The maximum current for the specific circuit shall be calculated in accordance with 706.30A1 through A5. 706.30A1 Nameplate rated circuit current. Circuit current shall be the rated current indicated on the ESS nameplate or system listing. Where the ESS has separate input charge and output discharge circuits or ratings, these shall be considered individually. Where the same terminals on the ESS are used for charging and discharging, the rated current shall be the greater of the two. 706.30A2 Inverter Output Circuit Current. The maximum current shall be the inverter continuous output current rating. 706.30A3 Inverter Input Circuit Current. The maximum current shall be the continuous inverter input current rating when the inverter is producing rated power at the lowest input voltage. 706.30A4 Inverter Utilization Output Circuit Current. The maximum current shall be the continuous AC output current rating of the inverter when the inverter is producing rated power. 706.30A5 DC to DC converter output current. The maximum current shall be the DC to DC converter continuous output current rating. 706.30b Conductor ampacity. The ampacity of the feeder circuit conductors from the ESSs to the wiring system serving the loads to be serviced by the system shall not be less than the greater of the one nameplate's rated circuit current as determined in accordance with 706.30a1 or a2, the rating of the ESS's overcurrent protective devices. 706.30c Ampacity of grounded or neutral conductor. If the output of a single-phase, two-wire ESS output is connected to the grounded or neutral conductor in a single ungrounded conductor of a three-wire system or of a three-phase, four-wire Y-connected system, the maximum unbalanced neutral load current plus the ESS's output rating shall not exceed the ampacity of the grounded or neutral conductor. 706.31 Overcurrent protection. 706.31a Circuits and equipment. ESS circuit conductors shall be protected in accordance with the requirements of Article 240. Protection devices for ESS circuits shall be in accordance with the requirements of 706.31b through f. Circuits shall be protected at the source from the overcurrent. 706.31b Overcurrent device ampere ratings. Overcurrent protective devices, where required, shall be rated in accordance with Article 240 and the rating provided on the system serving the ESS and shall be not less than 125% of the maximum currents calculated in 706.30a. Exception. Where the assembly including the overcurrent protective devices is listed for operation at 100% of its rating, the ampere rating of the overcurrent devices shall be permitted to be not less than the maximum currents calculated in 706.30b. 706.31c Direct current rating. Overcurrent protective devices, either fuses or circuit breakers used in any DC portion of the ESS, shall be listed for DC and shall have the appropriate voltage, current, and interrupting ratings for the application. 706.31d Current limiting. A listed and labeled current limiting overcurrent protective device shall be installed adjacent to the ESS for each DC output circuit. Exception. Where current limiting overcurrent protection is provided for the DC output circuits of a listed ESS, additional current limiting overcurrent devices shall not be required. 706.31e Fuses. Means shall be provided to disconnect any fuses associated with ESS equipment and components when the fuse is energized from both directions and is accessible to other than qualified persons. Switches, pullouts, or other similar devices that are rated for the application shall be permitted to serve as a means to disconnect fuses from all sources of supply. 706.31f Location. Where circuits from the input or output terminals of energy storage components in an ESS pass through a wall, floor, or ceiling, overcurrent protection shall be provided at the energy storage component end of the circuit. 706.33 Charge control. 706.33a General. Provisions shall be provided to control the charging process of the ESS. All adjustable means for control of the charging process shall be accessible only to qualified persons. 706.33b Diversion Charge Controller. 706.33b1 Sole means of regulating charge control. An energy storage system employing a diversion charge controller as the sole means of regulating charging shall be equipped with a second independent means to prevent overcharging of the storage device. 706.33b2 Circuits with diversion charge controller and diversion load. Circuits containing a diversion charge controller and a diversion load shall comply with the following. 1. The current rating of the diversion load shall be less than or equal to the current rating of the diversion load charge controller. The voltage rating of the diversion load shall be greater than the maximum ESS voltage. The power rating of the diversion load shall be at least 150% of the power rating of the charging source. 2. The conductor ampacity and rating of the overcurrent device for the circuit shall be at least 150% of the maximum current rating of the diversion charge controller. 706.33b3 ESS using interactive inverters. Systems using interactive inverters to control energy storage state of charge by diverting excess power into an alternate electric power production and distribution system, such as a utility, shall comply with 706.33b3a and b3b. And here it is, B3A and B. A. These systems shall not be required to comply with 706.33b2. B. These systems shall have a second independent means of controlling the ESS charging process for use when the alternate system is not available or when the primary charge controller fails or is disabled. 706.33c Charge controllers and DC to DC converters. Where charge controllers and other DC to DC power converters that increase or decrease the output current or output voltage with respect to the input current or input voltage are installed, all of the following shall apply. There's 2. 1. The ampacity of the conductors in the output circuits shall be based on the maximum rated continuous output current of the charge controller or converter for the selected output voltage range. And 2. The voltage rating of the output circuits shall be based on the maximum voltage output of the charge controller or converter for the selected output voltage range. 706 Part 5. Flow battery energy storage systems. Part 5 applies to energy storage systems composed of or containing flow batteries. Informational note: due to the unique design features and differences in operating characteristics of flow batteries as compared with that of storage batteries, such as lead acid or lithium ion batteries, the requirements for flow batteries have been included here rather than in Article 480. 706.40 General. All electrical connections to and from the system and system components shall be in accordance with the applicable provisions of Article 692. The system and system components shall also meet Parts 1, 2, and 3 of this article. Unless otherwise directed by this article, flow battery energy storage systems shall comply with the applicable provisions of Article 692. And that's flow batteries, by the way, 692. 706.41 Electrolyte classification. The electrolytes that are acceptable for use in batteries associated with energy storage systems shall be identified by name and chemical composition. Such identification shall be provided by readily discernible signage adjacent to every location in the system where the electrolyte can be put into or taken out of the system. 706.42 Electrolyte containment. Flow battery systems shall be provided with a means for electrolyte containment to prevent spills of electrolyte from the system. An alarm system shall be provided to signal an electrolyte leak from the system. Electrical wiring and connections shall be located and routed in a manner that mitigates the potential for exposure to electrolytes. 706.43 Flow controls. Controls shall be provided to safely shut down the system in the event of electrolyte blockage. 706.44 Pumps and other fluid handling equipment. Pumps and other fluid handling equipment are to be rated, specified, suitable for exposure to the electrolytes. 706 Part 6 Other energy storage technologies. Part 6 applies to energy storage systems using other technologies intended to store energy and when there is a demand for electrical power to use that stored energy to generate the needed power. 706.50 General. All electrical connections to and from the system and system components shall be in accordance with the applicable provisions of this code. Unless otherwise directed by this article, other energy storage technologies shall comply with the applicable provisions of Part 3 of Article 705. That brings us to the end of Article 706, and that thing that said Part 3 of 705 at the end, that was obviously a mistake that the NEC made because there is no Part 3 of Article 705 in the 2020 NEC. They must have meant Part 3 of Article 706, guys. Get it right. This is Sean White, over and out, signing off, Radio 706. Ba-dum-ba-ba-da, ba-da-ba-da-ba-da-ba. Thank you for listening to Sean White's Solar and Energy Storage Podcast. You can find out more about Sean White at his links page at solarshawn.com. Thanks for listening. Woo!